While Russia has been developing the PAK-DA stealth bomber, its actual existence as a fully operational or even prototyped aircraft remains largely uncertain and subject to significant delays and challenges. It's more accurate to describe the PAK-DA as a program in development with an uncertain future rather than a confirmed, deployable asset. Program overview and intentions. The PAK-DA, which stands for Prospective Aviation Complex for Long-Range Aviation, is envisioned by Russia as a next-generation stealth strategic bomber. It is intended to either complement or eventually replace Russia's aging Tu-95 Bear and non-stealth Tu-160 Blackjack bombers. The design concept is a tailless, long-range flying wing, prioritizing stealth to penetrate modern defenses, similar to the American B-2A and B-21 bombers. It is designed for subsonic speeds, emphasizing lower observability and the ability to operate closer to well-defended targets before deploying weapons. On paper, the PAK-DA is designed to have internal weapons bays, long endurance, and a crew sized for complex missions. It is expected to carry a payload of up to 30 tons, including both conventional and nuclear munitions, and have an operational range of 12,000 kilometers with the ability to remain airborne for up to 30 hours. The bomber is anticipated to be equipped with advanced precision-guided weapons, including hypersonic missiles like the KH-95 and KH-BD cruise missiles. Stealth features are central to its design, incorporating radar-absorbent materials and a reduced radar cross-section. There is speculation about the inclusion of advanced technologies such as lasers and tethered drones for reconnaissance and target acquisition, and artificial intelligence integration for operational capabilities. The PAK-DA program has faced numerous delays and significant hurdles. While initial reports from 2020 suggested 3 prototypes might be ready for preliminary testing by April 2023, and state tests could begin in February 2026, there have been no confirmed reports of a prototype being completed as of June 2025. The official launch of the program with funding began in 2008, with R&D contracts awarded in 2009. The final draft of the bomber was reportedly approved in February 2019, and construction of initial components began in late 2019, with TASS reporting the start of the first PAK-DA bomber's construction in May 2020. Production planning in May 2022 indicated ongoing component production for 6 PAK-DA aircraft, with multiple prototypes expected between 2023 and 2026. However, the program is challenged by engine development issues, material shortages, and a defense industry strained by the war in Ukraine and international sanctions. A significant hurdle is the development of a reliable, fuel-efficient engine that can also manage the large electrical loads of a stealth jet. Russia's UEC Kuznetsov has struggled to modernize the NK-32 engine for the Tu-160M bombers, with reports of bench test failures and missed deadlines. Developing a new engine tailored for a flying wing's airflow and thermal needs is even more complex. The first tests of the PAK-DA engine were initially scheduled for 2020 and were expected to be completed by the end of 2021, with a prototype engine reportedly nearing completion in December 2020. Stealth technology requires precise manufacturing processes, including high-quality composite materials, specialized tooling, and advanced coatings. Russia is attempting to achieve this while under heavy sanctions, which restrict access to specialized machine tools, microelectronics, and raw materials. These limitations lead to slower progress, increased rework, and a longer timeline from prototype to a reliable fleet. The war in Ukraine has shifted Russia's defense industrial focus towards immediate needs like artillery shells and drones. Resources are also being poured into refurbishing and upgrading existing Tu-160s, which ties up the same plants, engineers, and test infrastructure needed for the PAK-DA. This competition for resources and funding, along with the economic strain from sanctions, makes it difficult to commit fully to a new capital-intensive project like the PAK-DA. The modernization of the T-160M provides a more immediate and unglamorous solution for long-range strike capabilities by launching standoff missiles from safe airspace. Comparison with international developments. While Russia is striving to develop the PAK-DA, the United States is already fielding its second stealth bomber fleet with the B-21 Raider, which is currently undergoing test flights. China is also advancing with its own H-20 stealth bomber program, benefiting from experience gained with its J-20 and J-35 fighters. These developments highlight that Russia risks falling behind in the global race to build and sustain a low observable long-range bomber fleet at scale. Conclusion. Although the PAK-DA has been a planned project for a long time, with its design and certain components under development, there is no concrete evidence of a flying prototype. The program is plagued by significant technical and logistical challenges, exacerbated by sanctions and the redirection of resources due to ongoing conflicts. While a prototype might eventually appear, building a reliable and operational fleet in meaningful numbers seems unlikely in the near future. The PAK-DA currently remains more of a strategic ambition and a symbol of Russia's aerospace aspirations rather than a confirmed, active strategic bomber.